What we're going to do today is talk about a new test, and it's called the nth term test, and it's called the nth term test for divergence. So what this test says is that if you have a series, it's going to diverge if the limit as n approaches infinity of a sub n doesn't exist or is not equal to 0. If the limit as n approaches infinity of a sub n equals to 0, the test fails, which means it is inconclusive. Our second one is called the ratio test. We're going to have our series, a sub n, be a series positive terms only. And if the limit as n approaches infinity of a sub n plus 1 over a sub n equals to L, then there's a couple things that we look at. If L is less than 1, the series converges. Now let's stop and think about why it's going to converge. What does a sub n plus 1 mean in relationship to a sub n? You know, when you're writing out your terms, you have a1, a2, a3, an. What comes after that? A sub n plus 1. So what this is saying is that the ratio of the next term divided by the previous term, which is L, is going to be less than 1. So that means L is less than 1 when the terms are getting smaller. Likewise, if we say the limit is greater than 1, can you guess? The series is going to diverge. And then lastly, if L equals to 1, the test is inconclusive and it fails. So I want us to determine if the series converges or diverges. Sum as n equals 1 to infinity of 2 to the n over n plus 1. Nth term test basically says we need to take the limit as n approaches infinity of 2 to the n over n plus 1. This is the limit as n approaches infinity. You've got an exponential function on top, polynomial function on the bottom. Which one's growing faster? This is going to infinity. The limit diverges, so therefore it diverges. So we say by the nth term test, the series diverges. Now what I'd also like to show you is another way how we can show the ratio test can work with this one as well. So the ratio test says that you need to find L, the ratio of the next term divided by the previous term. So that means the next term will be 2 to the n plus 1 over n plus 2 divided by 2 to the n over n plus 1. So I'm going to flip the bottom fraction. So it's going to be 2 to the n plus 1 over n plus 2 times n plus 1 over 2 to the n. N plus 1 over n plus 2. If we look along the diagonal, these two over here, as n gets really, really, really large, the plus 1 and the plus 2 don't matter, so those are going to cancel out. If we look at the other two that are left, the 2 to the n plus 1 and 2 to the n, those do not completely cancel out, so this tells me that my limit equals to 2. L equals to 2, which is greater than 1, so therefore the series diverges. Let's try n equals 1, negative 1 over 8 to the n power. If you like, you can think of it as n equals 1 and then a negative 1 over 8 to the n. Let's try the nth term test. N is getting really, really large. What are we multiplying by every time? Now, go back and look. Was this a good thing or a bad thing? Actually a bad thing, because we don't want it to be 0. This is inconclusive. Let's try the ratio test. Can we use the ratio test? Actually no, because all of our terms are going to be negative. So what's left? Those are the only two tests we learned how to use. Don't forget, guys, this is actually a geometric series. Could have started with this to begin with. You're multiplying by 1/8 every time. Therefore, the series converges. So let's take a look at this one. N to the 10th over 10 to the n. Is it geometric? Let's try starting with that one this time. Do you think we can try to use the nth term test? Nth term test again means you got to take the limit. Can we take the limit? As n approaches infinity, n to the 10th over 10 to the n, which one's growing faster? Unfortunately, the exponential function grows faster, so this is going to be 0. Again, inconclusive. And if you write that 0 out, here's a little hint for you. You draw a little sad face because we don't want the zeros. It's not a smiley face. So let's now try the ratio test. So we need to have the ratio of the next term divided by the previous. So it'll be n plus 1 to the 10th over 10 to the n plus 1. Now I need to divide by that. I'm going to go ahead and also just multiply by the reciprocal. 10 to the n over n to the 10th. Okay, so n plus 1 to the 10 and n to the 10th, those are going to completely cancel out because as n is getting really big, plus 1 is not going to matter. Now look at what else you have left. 10 to the n and 10 to the n plus 1. You're going to leave yourself with the 10. So this limit equals to 1/10. So the limit is 1/10. It's less than 1. Therefore, our series converges. N times sine 1 over n.
Okay, we're going to go ahead and use the nth term test, which says that we need to calculate the limit as n approaches to infinity of n times sine 1 over n. Now, how do we evaluate this limit? N is approaching infinity, and sine 1 over n is approaching 0. This is really infinity times 0. This is an indeterminate form. So we are going to rewrite this a little bit so we can consider it using L'Hopital's rule, or maybe we can even do it a little bit easier than that. If we look at this as sine 1 over n over 1 over n, this is one of those special limits. This is very much like limit as x approaches 0 of sine x over x. This limit is equal to 1. So what do we have? If the nth term test is equal to some number, not 0, it diverges. Okay, we're going to do one last one, and it's going to be the sum from n equals 1 to infinity of 1 plus 1 over n to the n. This is not geometric, so again, let's take a look at the nth term test, and that means we need to take the limit as n approaches infinity of 1 plus 1 over n to the n, e to the limit as n approaches infinity of ln of 1 plus 1 over n to the n. So this limit equals to 1, so our answer is e to the 1. Okay, so basically what did we get here? This limit equals e. The series diverges.